Hello, welcome to the next Architecture Weekly webinar. Today we will be discussing one of the groundbreaking white papers, because this is the Papers We Love series. And we'll start with not technical document this time, but social technical. So the document that is called How Do Committees Invent by Mel Conway, where he coined his famous Conway law. And I think that this is already law that is known to all of you, but I'm not sure if all of you have read the original paper. So I think it will be a good opportunity to get back in time, because it's 1968, and discuss and see what was precisely written there. So let me share the screen. I hope that you can see the screen. As always, feel free to ask any questions as they will be coming. I will be reading out loud this paper, and stopping where I have something more to add. We'll see how much interaction we'll have. But in case you have any questions or you would like to chime in, then feel free to do it. As you can see, this is quite old paper and probably scanned because the font is not so precise. So let's go. So how do committees invent? That kind of intellectual activity which creates a useful whole from its diverse party may be called the design of a system. Whether the particular activity is the creation of the specification for a major weapon system, the formation of a recommendation to meet a social challenge, or the programming of computer, the general activity is largely the same. And I think that's quite also, let's maybe stop here, because actually this first paragraph is touching what actually designing system or working on the software architecture system is. And as always, that's some sort of things that it's hard to describe. So it's a series of activity, or as some are saying, making decision about something that is important. And of course, that's not precise. So let's move further. Typically, the objective of a design organization is the creation and assembly of a document containing a coherently structured body of information. We may name this information the system design. It is typically produced for a sponsor who usually desires to carry out some activity guided by the system design. For example, a public official may wish to propose legislation to avert a recurrence of a recent disaster, so he appoints a team to explain the catastrophe. Or a manufacturer needs a new product and designates a product planning activity to specify what should be introduced. Um, the design organization may or may not be involved in the construction of the system it designs. Frequently, in public affairs, there are policies which discourage a group acting upon its own recommendation, whereas in private industry, quite the opposite situation often prevails. So it seems that it's not yet about the IT at all, but as the title suggests, so how we are settling up the group to tackle the specific problem, the specific challenge. So for instance, working group on some new law, etc. It seems reasonable to suppose that the knowledge that one will have to carry out one's own recommendation, or that this task will fall to others, probably affects some design choices which the individual designer is called upon to make. Most design activity requires continually making choices. Many of these choices may be more than design decision. They may also be personal decision the designer makes about his own future. As we shall see later, the incentives which exist in a conventional management environment can motivate choices which subvert the intent of the sponsor. Um, so yeah, so at this moment, definitely, we are not always reasonable. I mean, we are reasonable, but as humans, we are mostly caring about our own life. So it's great that we have friends and colleagues in our work, but quite often it may appear that their decision are not because this is the best decision that they can make at this specific time, but this is as the best decision for their career, for their life, for their advantage. So we need to always remember that working, we it's great to have friends, it's great to have colleagues, but in the end it's a business, it's a work, not like the regular life. And people, we are all humans, and we take the priorities on our own lives. And the critical part here is to align that and to form the group that their goals, their personal goals, will be close to the group goals. But yeah, side note from me. Stages of design. The initial stages of a design effort are concerned more with structuring of the design activity than with the system itself. The full-blown activity um, the full-blown design activity cannot proceed until certain preliminary milestones are passed. These include, let me just check if I have a proper mic. Yes. These include understanding of the boundaries, both of the design activity and on the system to be designed, placed by the sponsor and by the world's realities. Achievement of a preliminary notion of the system's organization so that design task groups can be meaningfully assigned. We shall see in the detail later that the very act of organizing a design team means that certain design decisions have already been made, explicitly or otherwise. Given any design team organization, there is a class of design alternatives which cannot be effectively pursued by such an organization because the necessary communication paths do not exist. Therefore, there is no such thing as a design group which is both organized and unbiased. So yeah, so like in nowadays where the AI or generative AI is like really on the like the most hyped term right now, then many people believe that if the decisions are made based on the algorithm or some machine learning, etc., then they are unbiased and they are objective, while they're as unbiased and objective as the people that provided the training data and fine-tune the algorithm. So there is no such thing as unbiased stuff. There is always a bias. Once the organization of the design team is chosen, it is possible to delegate activities to the subgroups of the organization. Every time a delegation is made and some body's scope of inquiry is narrowed, the class of the design alternatives which can be effectively pursued is also narrowed. So yeah, definitely, if we are giving a set of scope to the specific subgroup, then we are also narrowing. That's obvious. Once scopes of activity are defined, a coordination problem is created. Coordinating among task groups, although it appears to lower the productivity of the individual in the small group, provides the only possibility that the separate task groups will be able to consolidate their efforts into a unified system design. Thus, the life cycle of a system design effort proceeds through, through the following general stages. Drawing of boundaries according to the ground rules, choice of a preliminary system concept, organizing the decision activity and the delegation of tasks according to that concept, coordination among delegated tasks, consolidated of the sub-designs into a single design. So kind of that looks like a waterfall because at this time it was really popular, and unfortunately it is popular. Nowadays it's just called safe, because it worked this way. So first we were designing and defining what teams will be working on our stuff, what approach will we choose, so the preliminary system concept, and then breaking down the tasks and assigning them to the specific teams. And then once we have the design, the groups come up with the design, then we need to coordinate their efforts. And after that, we need to cross our fingers and hope for the best that in the end we would be able to consolidate that and merge that. There was in Poland one project for the health industry where it was going for a few years, cost a few billions of Polish zlotys, so like billions of euro also. And in the end, they decided that they will drop this because it appeared that after those few years, when it was already delayed, that to consolidate and merge all of those pieces that were working by the different companies and different groups would cost more than they already spent. So it was better decision to ignore that and to drop this idea than wasting more money. So sometimes, indeed, this part can be really, really, really challenging and cost a lot. It is possible that a given design activity will not proceed straight through this list. Yeah, as we discussed. It might conceivably reorganize upon discovery of a new and an obviously superior design concept, but such an appearance of uncertainty is unflattering, and the very act of voluntarily abandoning a creation is painful and expensive. Of course, vantage point of the historian, the process is continually repeating. This point of view has produced the observation that there is never enough time to do something right, but there is always enough time to do it over. Yeah, so that's like how we do. So when we start, then we always start with the refactoring, rebuilding, throwing away the previous idea and starting over. That's always the best idea when we see some legacy system or something that wasn't made by us or that was made by old us from the past. And of course, this part about the superior design concept is also quite important because this is like why waterfall was never working well, because there are always some surprises, there are always some changes of the requirements, and because of that, even if we come up with the best plan, then there will be always something popping out because we are working in a really chaotic and unpredictable environment. And I think that Barry O'Reilly, with this residuality theory, is on point there, that there is not possible in the bigger systems to predict anything. So let's continue. The design system. Any system of consequence is structured from smaller subsystems which are interconnected. A description of a system, if it is to describe what goes on inside the system, must describe the system's connection to the outside world, and it must delineate each of the subsystem and how they are interconnected. Dropping down one level, we can say the same for each of the subsystems, viewing it as a system. This reduction in scope can continue until we are down to a system which is simple enough to be understood without further subdivision. So this is precisely what we are trying to achieve with the breaking down our task into smaller pieces, and hope that at some point we will be able to to estimate it or define what exactly has to be done and how long will it take. And that's also one of the points of those discussion: estimation versus no estimations. So if estimations are uh, guessing, then requirements are rumors, right? Examples. A transcontinental public transportation system consists of buses, trains, airplanes, various types of right-of-way parking lots, taxi cabs, terminals, and so on. This is a very heterogeneous system. That is, the subsystems are quite diverse. Dropping down one level, an airplane, for example, may possess subsystems for structure, propulsion, power distribution, communication, and payload packaging. The propulsion subsystem has fuel, ignition, and starting subsystem, to name a few. It may be less obvious that a theory is a system in the same sense. It relates to the outside world of observed events where it must explain, or at least not contradict them. It consists of the subtheories which must relate to each other in the same way. For example, the investigation of an airplane crash attempts to produce a theory explaining a complex event. It can consist of sub-theories describing the path of the aircraft, its radio communication, the manner of its damage, and its relationship to nearby objects at the time of the event. Each of these, in turn, is a story in itself which can be further broken down into finer detail to the level of individual units of evidence. Linear graphs. Figure 1, so this one, illustrates this view of a system as a linear graph, a tinker toy structure with branches, the lines, and nodes, the circles. Each node is a subsystem which communicates with the other subsystem along the branches. So like this one. In turn, each subsystem may contain a structure which can be similarly portrayed. The term interface, which is becoming popular among systems people, refers to the inter-subsystem communication path or branch represented by a line. In figure 1, alternatively, the interface is the plug or flange by which the path coming out of the node couples to the path coming out of the nodes. So as we see here, the system shows at the top communicates with the outside world through the three interfaces, 1, 2, and 3. The middle figure shows the major subsystem, which two of which are shown in the details at the bottom. So those are interfaces, 1, 2, 3. Then we have subsystems, and we can also visualize them as this one. And for me, this part is already a bit slicky, because I'm sure that we will see later on that this categorization is not always correct, but our systems are rarely so easily to categorize and put into the boxes, because there is a gray matter. Let's say that we have multiple teams and we have the classical organization structure, which is top down. We have departments and we have teams, and inside teams we have people. And in theory, each of those people have assigned the responsibilities. And that looks great on the paper because we shape the boundaries, we shape the communication. But as we know, there are always some people that has to do more, that has to connect those pieces or take over some stuff from the other team or do stuff more than they are assigned. And the similar to our systems that we are building, they are not always doing what we design on paper, and quite often those are not like a distinct sets, but more like a overlapping sets of responsibilities. So that's a perfect view of how we can break down. but definitely it's not real, at least in most of the cases. So let's move further. Relating the two, the linear graph notation is useful because it provides an abstraction which has the same for the two entities we are considering, the design organization and the system it designs. This can be illustrated in figure 1 by replacing the following words. Replace system with committee, replace subsystem with subcommittee, and replace interface by coordinator. So it's quite close to what I said, but not precisely. It's still quite rigid. Just as with subsystem, we find that design groups can be viewed at several levels of complication. The federal government, for example, is an excellent example of the design organization with enough complexity to satisfy any system engineer. This is a particular interesting example for showing the similarity of the two concepts being studied here because the federal government is both a design organization, designing laws, treaties, and policies, and a design system, the constitution being the principal preliminary design document. A basic relationship. We are now in the position um, to address the fundamental question of the article. Is there a predictable relationship between the graph structure of a design organization and the graph structure of the system it designs? The answer is yes. The relationship is so simple that in some cases it is an identity. Consider the following proof. Let us choose arbitrarily some system and the organization which design it. And let us then choose equally arbitrarily some level of complication of the design system for which we can draw a graph. Our motivation for the arbitrariness is that if we succeed in demonstrating anything interesting, it will hold true for any design organization and level of complication. Figure 2 shows, for illustration purposes, a structure to which the following statements may relate it. So figure 2 is this one. We will scroll to it again soon. For any node of x in the system, we can identify a design group of the design organization which design x, a lot of design. Call this capital X. Therefore, by generalization of this process, for every node of the system, we have a rule for finding a corresponding node of the design organization. Notice that this rule is not necessarily one-to-one. That is, the two subsystems might have been designed by a single design group. So again, a node X in the system, we can identify design group, the design organization, which can be design X, call this capital X. Okay. So yeah, like this sentence that two subsystems might have been designed by a single design group. Yeah, quite often we have more microservices than people. But yeah, nevertheless, let's move on. Interestingly, we can make a similar statement about branches. Take any two nodes X and Y of this system. Either they are joined by a branch or they are not. That is, either they communicate with each other in some way meaningfully to the operation of the system, or they do not. If there is a branch, then the two not necessarily distinct design groups X and Y, which design the two nodes must have negotiated and agreed upon an interface specification to permit communication between two corresponding nodes of organization, which is an optimistic assumption because most of the time people don't discuss the contract. It just happens or doesn't. So they are usually ending with the lowest common denominator of the quality of the communication. But okay, sometimes they do. Let's say, because this is like a discussion of the proof. So let's move on. If on the other hand, there is no branch between X and Y, then the subsystems do not communicate with each other. There was nothing for two corresponding design groups to negotiate, and therefore there is no branch between X and Y. What have we just shown? Roughly speaking, we have demonstrated that there is very close relationship between the structure of a system and the structure of the organization which designed it. In the not unusual case where each subsystem had its own separate design group, we find that the structure, in example, the linear graphs of the design group and the system are identical. In the case where some group designed more than one subsystem, we find that the structure of the design organization is a collapsed version of the structure of the system, with the subsystem having the same design group collapsing into one node representing that group. So this kind of structure preserving relationship between two sets of things is called homomorphism. Speaking as a mathematician might, we would say that there is a homomorphism for the linear graph of a system to the linear graph of its design organization. Okay, that's a lot to cover here. So let's have a look on the figure number 2 to make it a bit more clear. So figure 2, here is an illustration of the strong relationship between the structure graph of a system left and the structure of the organization which designed it, so right. So here we have the system, and here we have the design organization. So first, so this is like a system with 3 various interfaces, 1, 2, 3. So this is the same. And then we have the connection between subsystem and interfaces that communicate between each other. So 4 and 5. And here, those arrows represent the designed by team and correspondence and communication. So as we see, some subsystems might be designed by multiple teams, but if there is some interface between those systems, then it means that there needs to be some sort of relationship. It might not be like a really straightforward and explicit interface discussed, but there has to be something. Because if those two teams, and let's keep our IT for a reference, let's say that 2 teams are working on the components that are communicating with each other, then there has to be some sort of communication. It doesn't have to be like a communication like face-to-face, or maybe having some calls between teams. There can be, for instance, some team is publishing some package like a NuGet package or NPM or a Maven package, or they are just sharing publicly their code in the repository that some other team might decide to use. But then this is like some sort of communication, implicit communication, and some sort of implicit emerging contract. And of course, there might be, this is not a perfect case where we are just throwing some code or throwing some component and accidentally some other team decides to use it. But as we know, that actually happens. So if there is no communication between between those components, then definitely the communication between the teams might not need to happen. Of course, we can have some relationship like talking during coffee breaks or, just exchanging the ideas. But in terms of designing system, there might not be any relationship between teams. So because of that, we have this homogeneity that if the component has to talk to each other, then definitely there has to be some sort of way, explicit or implicit, for the teams to coordinate and to have this communication. So the structure of the organization and the teams might be impacting, but we will be for sure discussing that in the next paragraphs. So system image, these design groups. It is an article of faith among experienced system designers that given any system design, someone someday will find a better one to do the same job. In other words, it is misleading and incorrect to speak of the design for a specific job unless this is understood in the context of space, time, knowledge, and technology. The humility which this belief should impose on system designer is the only appropriate posture for those who read history or consult memories. And I fully agree. This is extremely important because we are not humble enough in our industry. And quite often, we don't know yet the domain. We don't know the team that we will be. We don't know the budget, but we already know which technologies will we choose or which design patterns will we choose. So this is what Mel Conway is talking here. So the context of space-time technology, design is not coming out in a vacuum. We should always think about everything that is surrounding us. So our system environment, both that happens inside our organization and outside. The design progress of computer translators of programming language such as Fortran and COBOL is a case in point. In the middle 50s, when the prototypes of this language appeared, their compilers were even more cumbersome objects than the giant, for then, computers which were required for their execution. Today, these translators are only historical curiosities bearing no resemblance in design to today's compilers. We should take a particular note of the fact that the quantum jumps in the compiler design progress were associated with the appearance of new groups of people on territory previously trampled chiefly by computer manufacturers. First, it was the tight little university research team, followed by the independent software house. Yeah. If then it is reasonable to assume that for any system requirement, there is a family of system design which will meet that requirement, we must also inquire whether the choice of design organization influences the process of selection of a system design from that family. If we believe our homomorphism, then we must agree that it does. To the extent that an organization is not completely flexible in its communication structure, that organization will stamp out an image of itself in every design it produces. The larger an organization is, the less flexibility it has, and the more pronounced is the phenomenon. So, yeah, I'm sure that many of you are working or have been working in the like enterprise systems, and indeed in such type of systems you have the procedures, you have the set, for instance, set of accepted technologies, you have a set of accepted methodologies, you have a set of accepted external parties that can work with you. And with such procedural and rigid environment, then obviously those requirements and way of working will be more rigid, and you will more likely tend to fall into the rails because you cannot do much more because you have this rule. Like, you want to do a new system, okay, then you need to use one of those technologies. You want to form a team, okay, then you need to use this methodology to work with the teams. And not surprisingly, those systems are designed in a similar way. So quite often they are like big monoliths or big ball of mud, where in theory you have this modular split, but then because of the people trying to find workarounds of the organizational issues, they are baking those tweaks and hacks into the software to somehow overcome the deadlines or be able to deliver something. Okay, a bit of rant about enterprise architecture and enterprise teams, but to be true, I never managed to stay longer in the project than year and a half or 2 years in the really like a big enterprise software. Of course, I've been working more years, but I had to do some breaks between them. Not my favorite cup of tea. Okay, so let's see what examples Mel Conway brought. So examples, a contrast research organization had 8 people who were to produce a COBOL and an algal compiler. After some initial estimates of difficulty and time, 5 people were assigned to the COBOL job and 3 to those COBOL job. The resulting COBOL compiler ran in 5 phases. The algal compiler ran in 3. 2 military services were directed by their commander-in-chief to develop a common weapon system to meet their respective needs. After great effort, they produced a copy of their organization chart. So let's get back to the COBOL. So after, yeah, so 5 people were assigned to the COBOL and 3 to the algal job. The resulting COBOL compiler ran in 5 phases and algal in 3. Okay, that's nice. Going further, consider the operating computer system in use solving a problem. At a high level of examination, it consists of 3 parts: the hardware, the system software, and the application program. Corresponding to this, so see figure 3b. So application programs, software systems, software hardware. So we have programming language, machine language, user programmer, system programmer engineering, and yeah, and DevOps. Common logistics, weapon special to service A, weapon special to service B, and common logistic agency, service A, service B. Yeah. Corresponding to this subsystem, the respective designers, the computer manufacturer engineers, his system programmers, and the user application programmers. Those are rare instances where the system hardware and software tend to cooperate rather than merely tolerate each other, are associated with manufacturers whose programmers and engineers bear a similar relationship. True. System management. The structures of large systems tend to disintegrate during development qualitatively more so than with small systems. This observation is striking evident when applied to the large military information systems of the last dozen years. These are common of the most complex objects devised by the mind of man. An activity called system management has sprung up partially in response to this tendency of systems to disintegrate. Let us examine the utility to system management of the concept we have developed here. Why do large systems disintegrate? The process seems to occur in 3 steps, the first 2 of which are controllable and the third of which is a direct result of a homomorphism. First, the realization by the initial designers that the system will be large, together with certain pressures in their organization, make irresistible the temptation to assign too many people to a design effort. First, the realization by the initial that the system will be large, okay? Second, application to the conventional wisdom of management to a large design organization causes its communication structure to disintegrate. Third, the homomorphism ensures that the structure of the system will reflect this disintegration which has occurred in the design organization. So yeah, so to rephrase that, firstly, the initial designers, they predict and see already by the usually like a gut feeling or experience, call it what you want, that the system will be big enough and that it will require to tackle that in a smaller groups to make it somehow manageable and reduce the cognitive load. And then based on their common wisdom or like they try to break it into a separate group. And then the third, so those two parts are usually part of the planning or setting up, organizing how our project will be run or managing that during the how it is developed. And the third is like gravity. We will just, as we are splitting our system, then the people will be working in a subgroups. They will be focusing on their own sub parts, and then this will just happen. This disintegration into smaller pieces, because we already split our organization, then our system will be also work separately, sometimes communicated better or worse, but already dismantled. Moving on. Let us first examine the tendency to overpopulate a design effort. It is a natural temptation for the initial designer to the one whose preliminary design concept influenced the organization of the design effort to delegate tasks when the apparent complexity of the system approaches his limit of comprehension. So yeah, so it's like, as we said, trying to break down into manageable pieces. So as Mark Seman call it, the code that fits your head, or the problem that fits your head, or that fits the heads of the group. This is the turning point in the course of the design. Either he struggles to reduce the system comprehensibility and wins, or else he loses control of it. The outcome is almost predictable if there is a schedule pressure and a budget to manage. So yeah, so if we are kind of good, if we manage to build our muscles and we are good in having our gut feeling, or in other words, if we are lucky, then we can break down our system into smaller components, into smaller challenges to tackle and set up the teams right. But as we all know, setting boundaries is extremely hard. And then if we are, like, let's say we setting up the team leaders, we are giving them responsibility of the specific subsystems, then kind of we are losing control of it. And this is something which is expected, because that's why we are doing it, not to need to manage everything. But because of that, the outcome is, the unknown, because then we are losing control. We cannot control everything, but this will depend on the people that will be working on those specific subsystem or submodules on subparts of our project. And most importantly, about the coordinators. So those people that are coordinating those efforts. So I'm not saying about like a middle management or scrum masters. They might be them, but they might not. So right now I see that there is a trend to kill off the middle management. So those people that in theory are not doing anything important, because it's hard to see the outcome of their work, However, I think that those people are really, really important, because if we separate the effort, then someone needs to coordinate that. And people and teams are usually so focused on their job, and as they are getting the autonomy, then they are feeling so autonomous that they are losing the big picture, the view of the whole system. And because of that, those people, those coordinators, especially in the bigger projects, are really, really important. So, but yeah, a side note. Let's move on. We will get back to that, to maybe some stories from my battles and from my past projects. And if you have any stories to share or questions at this moment, feel free to ask or share it on the chat or with voice. Moving on. A manager knows that he will be vulnerable to the charge of mismanagement if he misses his schedule without having applied all his resources. This knowledge creates a strong pressure on the initial designer, who might prefer to wrestle the design rather than fragment it by delegation. But he is made to feel that the cost of risk is too high to take the chance. Therefore, he is forced to delegate in order to bring more resources to the bear. So, of course, as always, we like delegating tasks to other people is really hard. Everyone is saying like delegate to other people, but what does that actually mean? And usually when we are starting our journey as a technical leaders or managers, then we, especially if we are coming from a technical background, like we were developers, technical leaders, etc., then we tend to really try to manage everything. And we are thinking that we would do design the best we can. And then, of course, it's unavoidable, and management see that this is not possible, that the single person could manage that, because either that would end up with the micromanagement or just burning out of this leader, um, or just the team would not be happy, or the design would be really bad, because that's also a risk to put the whole responsibility of the design on a single person. So they are pushing manager to delegate more and to build like the teams that will take some of his duties. The following case illustrates another but related way in which the environment of the manager can be in conflict with the integrity of the system being designed. A manager must subcontract a crucial and difficult design task. He has a choice of two contractors: a small organization which proposes an intuitively appealing approach for much less money than is budget, and an established but conventional outfit which is asking a more realistic fee. He knows that if the bright young organization fails to produce adequate results, he will be accused of mismanagement. Whereas, if the established outfit fails, it will be evidence that the problem is indeed a difficult one. What is the difficulty here? A large part of it relates to the kind of reasoning about measurement of resources which arises from conventional accounting theory. According to this theory, the unit of resources is the dollar, and all resources must be measured using units of measurement which are convertible to the dollar. If the resource is human effort, the unit of measurement is the number of hours worked by each man times his hourly cost summed up for the whole working force. One fallacy behind its calculation is the property of linearity, which says that the two men working for a year or 100 men working for a year at the same hourly rate cost per man are resources of equal value. So it's like saying that 9 women will give one birth of a child in 1 month, which of course is not the case. Assuming that 2 men and 100 men cannot work in the same organizational structure, this is intuitively evident and will be discussed below. Our homomorphism says that they will not design a similar system. Therefore, the value of their efforts may not be even comparable. From experience, we know that the 2 men, if they are well chosen and survive the experience, will give us a better system. Assumptions may be adequate for peeling potatoes and erecting brick walls fail for design system. So yeah, you all saw that. I'm always saying that if project is delayed or behind the budget, the worst thing that you can do is to add more people, because then those people that are already skilled enough, familiar with the system, with the constraints, they will stop producing the outcome because they will need to onboard new people, and by that they won't be delivering. So usually what I'm suggesting is either trying to cut scope or as postpone deadline. There are no deadlines that cannot be postponed. Like I didn't so see that in my whole career, which is over 17 years long. Sorry. And really, any deadline can be postponed. So I would say that first, uh, just try to stabilize stuff, deliver what you can in the scope that you have, then make a retrospective, maybe then decide whether you should really get more people, or maybe you should change the way of working. But adding new people and hoping that just by adding new people you'll be able to deliver more, that's not going to happen. And especially I was in a few greenfields when they were trying to scale up, because if you are a greenfield, especially if you are VC baked, so you have sponsors that are pouring money on top of you, then you need to show growth. You don't always need to show the outcome, but you need to show growth, because those VCs are investing because they are hoping that you will grow into some sort of unicorn, or if not into the unicorn, then at least that your business model will scale, and that the money that they put into your product will be multiplied by really high magnitude. So they don't need to have like a stable growth. They need to have extreme growth. So because of that, when you are getting the sponsor, then you need to show that you are growing, and then many people are hired. And as we saw recently, unfortunately, after that, there is always a moment when those people will need to be cut, unless you be lucky and you will build the unicorn and your hyper scaling mode will somehow succeed. But for a few product or dozens of projects, only one or two are like that. And for the rest, there is always a moment in a startup life when you realize that you don't have enough money, or your business model doesn't exist, or is not profitable enough. And then the situation and the over hiring is ending, and then it's not pleasant. I've been there and don't recommend that. So let's continue with what Mel Conway wrote. So Parkinson's law plays an important role in the assignment of design effort. As long as the manager prestige and power are tied to the size of the budget, he will be motivated to expand his organization. This is an inappropriate motive in the management of a system design activity. Once the organization exists, of course, it will be used. Probably the greatest single common factor behind many poorly designed systems now is in existence has been the availability of a design organization in need of work. And that's a great point, because we are optimizing for what we are measuring. And if manager, as I mentioned, will be will get the praise and the bonuses if the project will scale, then their focus won't be on like delivering best product, but on scaling. And that's what happens. So the important part is to select the proper measurements and the proper things that we want to achieve, and they need to correlate. So to be able to design a business outcome, then if we really need to have some measurements, and for sure we need to have, then they need to be business related. So the outcome related, not the output related. So for instance, uh, like how many business, like measuring the delivery by user satisfaction or growing business, like or how many users we are getting. So that part of or measuring whether we have less bugs or customer satisfaction. This is something that we should be measuring, not scaling our organization. Because then if we are scaling and then we need to break those people in the teams, and because we are breaking this big organization into smaller teams, then we need to assign them some work because they need to have some work. And most likely, as Mel Conway is saying, we will be breaking down our work to just be able to distribute the work between those people. And we might be spreading the jam too thin, as Gerald Weinberg is saying. So instead of focusing on delivering business, we will be focusing on managing and coordinating the effort, so something is delivered. The second step in the disintegration of the system design, the fragmentation of the design organization communication structure, begins as soon as delegation has started. Elementary probability theory tells us that the number of possible communication paths in an organization is approximately half the square of the number of people in organization. Even in a moderately small organization, it becomes necessary to restrict communication in order that people can get some work done. Research which leads to the technique permitting more efficient communication among designers will play an extremely important role in the technology of system management. So yeah, so definitely, like if we have two people, then there is only a single connection between them, right? Because they can only communicate with each other. If there is a third person, then we will need to then there will be like a two communication channel between each of them. So this will be like uh, um, free communication channel already. If we have four people, then there is even more ways of communicating. So like six. So and that is growing really. And the same goes for the teams. So and the more teams we have, the more spread it is the work, then the more communication channel it requires. And some may say like, okay, then we will have a single big team, but that also works inside the team. So if your team is too big, then inside the team, you won't be able to communicate and work together. I'm sure that you were on the Scrum stand-ups where you have like a 10 or 20 people and the stand-up lasted for like 45 minutes, like a typical nightmare. Common management practice places certain numerical constraints of the complexity of the linear graph, which represents the administrative structure of a military-style organization. Specifically, each individual must have at most one superior and at most approximately 7 subordinates. To the extent that organization protocol restricts communication along lines of command, the communication structure of organization will resemble its administrative structure. This is one reason why military style organization design system, which look like their organization charts. Conclusion. The basic thesis of this article is that the organization which designs systems, in the broad sense used here, are constrained to produce designs which are copies of the communication structure of the organizations. We have seen that this fact has important implication for the management of system design. Primarily, we have found a criterion of the structuring of design organization. A design effort should be organized according to the need of communication. This criterion creates problem because the need to communicate at any time depends on the system concept in effect at that time. Because the design which occurs first is almost never best possible, the prevailing system concept may need to change. Therefore, flexibility of organization is important to effective design. Ways may, must be found to reward design managers for keeping their organization lean and flexible. There is need for a philosophy of system design management, which is not based on the assumption that adding manpower simply adds to productivity. The McKinsey, hello. The development of such a philosophy promises to unearth basic questions about value of resources and techniques of communication, which will need to be answered before our system building technology can proceed with confidence. Whew. So let me stop sharing and let's discuss any questions from you. I'm not seeing any. So, from my perspective, this is clearly really applicable to the current world and the current state of our industry. So really, let me tell you the story. Like I was working in the product that was a startup, and we started as a one team or two teams. And then, as I mentioned, we had to grow and scale up extremely. And initially, the project was created in a single city. And then some other teams were added in other cities because it was needed to be able to find equality teams. And it was not so easy to find it within a single city. So it sounded like a reasonable move. And then because of that, because those cities were kind of located not so far away, but still far away enough not to meet regularly, then the tension appeared. And the management was trying to build the system based on like the latest, the greatest ideas about how to break the work. So in theory, each team was autonomous. Each team got its own business model to work with. So in theory, each team was equally important and each model was equally important. And all the teams have enough rights and enough responsibilities to find a way how to communicate with each other. But the reality was not how it looked like, because the most of the teams were located in the headquarters. So this initial city where the product was built. And because of that, there were always some chit-chatting during the coffee breaks, discussing. It was much easier for those teams to find those communication channels or interfaces, as Mel Conway discussed, than those teams that were working externally. And because of that, those external teams didn't know about anything, about everything, etc. And they weren't able to equally well communicate, and because of other, failures and reasons, then it wasn't going as it should, to say mildly. And it appeared that obviously, even though in theory all teams were equal, but like in a George Orwell Animal Farm, there is never the case where all teams and all communities are equal. And my my retrospective after that project, it was that we were trying to ignore the Conway law, and you cannot ignore the Conway law, or you cannot fight the Conway law, because it is like a gravity. It just happens, as we discussed during the learning. So from my perspective, maybe it would be better if we frankly say that, let's say that some teams are more important, or some modules are more important, because obviously, like, there are always some core domain modules and some supportive modules, and they are not equal. So if we model and understood the organizational structure, then maybe it would be easier to define those intended communication channel and work on them more efficiently. So if we say that, for instance, those teams that are in the headquarters, if they are saying that and you cannot agree to each other, then they have the final voice. Or maybe by assigning a specific, like the most important modules to the headquarters, or the modules that should communicate more with each other. So those are that have like a strict, close relationship, that they could better benefit from having the chance to talk during the coffee break, etc. Then maybe if we model the communication and the scope and the responsibility of that in this way, by embracing what is our organization, then it would be easier. Maybe it wasn't super pleasant to hear that you are not as important as the other teams, or your module is not as important as the other. But if it was explicitly said, then it would be something that either you are signing up for that or not. It's a clear relationship. And I think that nowadays it is popular, the team topologies, they are also coming from this discussion. So embracing what is our scope of our business and finding the best topology of our teams to embrace what we want to achieve and what we can achieve. And there is always so-called inverse Conway maneuver. And this inverse Conway maneuver is what I said. So shaping the teams and our organization to fulfill our needs. So it's like we are inverting and trying to benefit from the Conway law. So if we see that what we want to achieve and what organization we have already, and we understood the current situation, then maybe by shaping the teams instead of the technical responsibilities, then shaping them based on the business capabilities, or maybe building some teams that are responsible for coordinating and making like those popular right now platform teams. So like delivering not only technical but also business capabilities, like back offices to other teams, that could help. However, inverse Conway maneuver doesn't work always like that. We cannot always shape the organization as we want. If we are working with the rigid organization like big enterprise, or if we already have like a big legacy system where everything is tangled together, then it's, even if we break down our teams into the intended um, capability split, then they will be stepping on each other's toes, because the current system and the working on them will force them to work on the same places. So it's not so tricky to do. So Nick Tune wrote a really good book about architecture modernization, and I think that there are many heuristics there how to try to benefit both from Conway law, where inverse Conway maneuver um, can be efficient. So I also wrote the article that event-driven software can help in that, because if we are building our system in a way from technically that the communication is loosely coupled, and we understand that our modules can communicate with events or with commands, so with messages in general, then it's easier to understand that this is some sort of contract. And even if we don't understand that, that on the first failure, on the first breaking change that will break other people's work, we will quickly understand that there is a contract, that we need to work together. And by working together on this contract, maybe we can understand like, hey, okay, so let's discuss and let's understand those dependencies and those responsibilities and maybe work better and understand what is the constellation. Also, context maps can help on that to to model both technical dependencies and social technical, so team dependencies. So that's also a tool that I highly recommend. But always, I think that we should start with embracing the current state as it is. Then we can draw where we want to go, and then trying to find how to achieve. So thinking about the teams we have, their experiences, the organization, how much power we have to reshape the organization structure. If we have such power, then maybe we can try this inverse Conway maneuver. If we don't have, then probably that won't not going to work. And then we need to accept and try to work in a adjust our way of working and distributing the work the best way to be aligned with the organization, and then maybe following the Boy Scout rules step by step, trying to adjust that. So to end up, my running joke is that if we are working in a distributed systems, so both like microservices, but also like remote teams, then not always we are becoming an experts of the distributed systems, but we are becoming experts in the Conway's law. At least that's what I saw. So thank you. I will again post the links under the recording. If you have any questions, feel free to ask them on the Discord or in the comments under this post. And thank you for watching, for listening, and see you on the next episode of the Papers We Love or the other webinar. Cheers.